co-founder and CEO of a data science company. We are headquartered in Calgary. So today I'm going to talk about how we are actually applying machine learning to disrupt the new home construction industry, which is a lag industry. In new home industry is actually it's a very, very important industry that with more than it's one of the most important industries in the economy, with more than 1 million new homes being built every year, and with an average median home price of about $350,000 to $450,000 per home. This industry is really creating millions of jobs and generating hundreds of billions of dollars every year. However, there's a structural gap that is in this industry that every home builder faces. They have to make big dollar decisions with a blindfold on, and people in this industry aren't equipped with the latest technology to take actions. Their operations are typically reactionary in their decision-making are actually at the mercy of market conditions at all times. And that causes a risk aversion mentality in general pervasive in this industry. And that also leading to the lack of supply of the market that built up for the last decade. Now, as we face increasing uncertainty in this economic environment, like inflation and global supply chain issues, this change of paradigm will only make the market condition even more challenging for home builders. So in the last 10 years, they had supply chain certitude, low inflation, and low cost of capital. But in the next year, with the capital constraint and increasing supply chain issue, also labor shortage, all this environment actually imposing even greater challenge for home builders. So those are unable to acquire their own actionable insight to empower their operation or continue to make their key decision with limited visibility, they will no longer be able to stay profitable. So that's a structural gap that exists in this laggard industry. The cost to this structural gap is that most home builders are relatively fixed in their production capability. And this constraint, coupled with the laggard industry that practically non-existing data for economic and supply chain information or any actionable market data to help them to make timely decision. These inefficiency in decision-making further handicapped by their process and technology. So they also face very significant financial risk without any established risk management process and practices. In some extreme cases, for example, most recently, quite a few home builders are still celebrating the significant sales they actually had closed last year, but they're not realizing the risk exposure they have with the increased delay in the construction, and that will easily dry up their cash flow. So however, these make a trend while reinforcing the current challenge, the pandemic also actually helped accelerate the entire industry to become more digitally transformed. And they empower consumer to become a digitally empowered consumer that moving their buying behavior online in an accelerated pace. So this is actually creating an exciting opportunity for a new generation of home builder who are willing to invest in technology and consider using data-driven decision-making to empower their business as their competitive edge. So a little bit background about OpenHouse. We are a leading data science company for new home builder. We aim to equip home builder with the visibility and technology that required to modernize their operation, and we help them to learn from their data. To date, our technology already been deployed across more than 20 geo markets in US and Canada. We servicing more than 1 million unique visitors every year, and we help thousands of people found their home now online. We are also helping innovative builders to maximize profit through localized demand forecasting, optimize product selection, and simplify their operation by reducing the risk of their inventory management. So our ambition is to empower technology-enabled home builder to digitally transform the entire industry. We believe the future home building should put the buyer in the center, and every builder should deeply understand the need of the customer by collecting data about their behavior preferences, review preferences, and then also take those data to generate accurate demand forecasts That helped them to streamline their downstream operation and construction scheduling and deploy cloud-connected system. That allowed them to apply modern operational research practices and the machine learning technology so that they can actually optimize the entire business operation. We believe that technology can impact the entire value chain of the home building industry. So if you are a local home builder, even you're actually a national home builder, but when you actually operate in a local market, it's very local business. These builders face challenges that require pushing thousands of decisions every month and every day. A tech-enabled home builder will be able to access trusted and actionable information from the local and regional sources, and stakeholders should be able to apply value engineering by anticipating demand. Then they know exactly what home to build and identify the business driver that help them to make decisions and adjust the business in a timely manner. So we have created a advanced analytic and machine learning technology called a builder intelligence platform. We help builders to understand the need of their buyer and identify market opportunity in real time. With this visibility, also gathering a real-time operational feedbacks. So our customers are effectively executing their business strategy from sales all the way to operation. We help them to break the silo between the data that collected from traditional marketing function and the data that actually gather from the operations. So we help bridge them and actually creating optimization model for them so that they can know the feedback loop from the market and the operation. So we're now going to explore a few promising use cases that we have applied machine learning for the home building industry related to demand forecasting and operation decisions. So first of all, actually, we all know that any successful machine learning technology requires high quality of data. This industry, there's a general lack of data quality. So what we actually realized that a few years ago when we started, we have to really help home builders to collect meaningful first-party data. So how do we collect data? So in general, we actually create and develop a few very deliberate created data collection tool, but they all work in the same philosophy. So here's actually a high-level guideline. How do they work? So take a home buyer, Hannah, for example, come to the website or any web platform. As she browsing through the catalog or watching and finding a home on a home builder's website, the algorithm actually, we have these different type of recommender system trying to understand and observe their behavior to try to identify what are the home and option and product that actually this person is looking for. We adapt the result and then guide Hannah all the way through the entire journey. And then we also aggregate this information, anonymize them, pair them with local geo-intelligence information, and then we aggregate them to facilitate her decision-making. We run in real-time trial and observation to actually understand what is the most effective path for her to find a home. And we also apply those algorithms to help other buyers. So as we collect this data, we also kind of build two different types of product. That one type is like a recommender system powered quiz that we ask a few questions that's customizable by our customer, by home builders, to understand what's truly meaningful and most important for the home buying decision. So that's what we call guided home finder. But from a data collection perspective, we are using that to understand the aspirational preferences. In this case, if I use analogy to explain that, it's like when my wife asked me, what would I like to do tonight? I would say I'm going to read books. So this is a aspiration preference that typically salespeople will gather from a home buyer. But then our recommender system that powering the catalog, which can be deployed as a white label solution or a SDK that plug into the JavaScript. We basically gather information about the review preferences from a buyer. So with that, it's almost like when my wife asks me what I'm going to do, I say I'm going to read book. And if I sit down to watch YouTube, then YouTube will know what I'm actually really interested in tonight. So these are review preferences information that we gather. Combining the aspirational and review preferences, we actually are able to generate very accurate demand forecast model for home builder that inform their business operations. So this is an example of our demand forecasting engine, what kind of result it will be able to produce. So with this high quality of first-party data that we help home builder to produce, we're able to basically produce between 60 to 90 days sales forecast for the next quarter. This is actually quite significant for the industry. Traditionally, this industry rely on the sales team interview, information gathered from the marketing survey, or past historical sales to understand and anticipate what will be the sales for the next quarter or next year, and then they plan operation around this sales forecast accordingly. But if you think about even a sizable home builder that building 400 homes per year, which translates to a couple $100 million annual revenue. But 400 homes is only 400 data point. So that's from a statistic and machine learning perspective is a very, very limited data point to provide meaningful forecast. And when they apply that historical sales as estimation to the future, in machine learning term, that's basically the persistence algorithm. So here's the chart that you can see the blue line is actually the actual sales that happen. And the magenta line is basically the baseline forecast. You can see it's basically just a mirror of what happened. That is basically using persistence algorithm to say that would be my forecast. And you can see how wide that gap is. And that's the reason why a lot of operation in home building business always lag to what happened to the market reality. And here, the tier line is actually our algorithm using one type of technique that related to multivariate time series model that we're able to, based on the consumer behavior pattern change and the decision fingerprint, we're basically able to create very much better forecast model to anticipate sales 90 days ahead of time. So if you think about Netflix and Amazon, how they power consumer to discover content product and anticipating the demand and even be able to create these one-day delivery services. If Amazon are able to basically sell consumer product like that, why home are not being built the same way, right? So basically, we deploy our technology for home builders so that we can enable them to capture data from thousands of sessions online every month, rather than couple sales every month. So that creates much more accurate model and help them to analyze the pattern as they unfold. So using that, we're basically able to create this algorithm to deliver less than 10% error rate on our mathematical model. So with that, so we're going to get into the interesting part of operation research. Is with this accurate demand forecast, we apply stochastic modeling, queuing theory, and the optimization algorithm to help them truly streamline their operation. And that helped them to basically improve the efficiency of working capital and hence make the business much more profitable. So if you think about the operation of the home builder, the risk of operation for home builder that face is that they traditionally lack the demand visibility, as you can see in the persistence algorithm. So that's why they're always reactionary to the market demand. That actually poses quite a bunch of challenge for them. One is the material and labor cost erosion. That was not quite a biggest concern in the past for them, but in the future, this is going to be a huge challenge for them due to the supply chain issue and the inflationary environment that we're facing. Also, there's other things that's actually the contractor scheduling. If they have more certainty, they're able to actually negotiate better deal and providing better certainty for their downstream contractor to manage their business partner. They also can, without this visibility, they also sometimes face unpredictable blocker in their critical path of project management, and sometimes need to deal with urgent reprioritization, and that actually is cascading all this failure. So in this right-hand chart is actually a few analysis on the home construction industry that you can see there's a long tail on the right-hand side, that most of the time construction projects are on time and on budget. But when they're not on time and on budget, the problem is pretty severe, and the cost of overrun is actually very, very high. So that is the risk environment that they have to face without the demand forecast. There's another new challenge that's bring to the home building industry, is that as we enter this new era of empower consumer, people expect to actually have a different online experience. Now, due to this very relatively fixed capacity constraint that home builder face, they constantly needed to balance the trade-off between maximizing revenue by accommodating the choices the customer want to choose, or emphasizing operation simplicity. Now, in the past, actually, the market is relatively stable, but in this future, basically, it's all technically closely impossible to basically for them to balance that need in a reactionary way. So, how home builder can break the trade-off to create optimal operation for them? So they have one of the two paths. They can achieve low-cost accommodation by creating more and more digital-enabled service online, so allow customers to basically personalize their own buying options without actually inflating the cost. Or they can basically really targeting what are the most effective product line and most profitable product line for them, for the niche market that they want to attack, and then reduce the variance that allow to customize for those homes. That's actually how they can achieve operation efficiency. Now, the future that we basically see with the tech-enabled home builder are the builder who basically be able to operate in the optimal curve, that be able to operate in a certain agility to switch between the low cost of accommodation and balance the uncompromised reduction. So that basically lead to if home builder want to create this optimal operation, we basically need to help them to understand the queuing theory, and that's where queuing theory come into place. To optimize operation construction, these all different phases constructions like a queue. What they need to achieve is basically balancing the cost of waiting for the customer and complexity and the cost of service to find the optimal service level that they can provide while controlling the different variability that was introduced due to uncertainty in the market. There are 5 types of variability in the operation. One is arrival variability, that is related to the market demand, how many sales they will be produced for next quarter or next 6 months. And the request variability essentially is how much variance that was introduced by the customer's customization need. Also, capability variance is actually related to the different subcontractor capacity and the service level that is demanded from them, and the ability to what degree they're able to optimize, and also subjective preference variance from the customer. Now, traditionally, this is close to impossible to use classic technique to do that, because if you look at the service costs, wasting costs, these are all a certain statistical distribution that is not a fixed number. What is a combined effect when all these different uncertainties come together, that making the optimal service level is really unknown number for them, and it's constantly changing. So that's why using traditional analytical model to analyze queue is not sufficient. So I'm going to quickly cover, there's 2 different approaches traditionally in operational research to analyze queuing models. One is analytical models. This typically applicable to simple cases, right? So a common and very well-known formula is Little's law, where the work in progress equals the lambda arrival rate multiplied by the wait time. But there's a huge issue with this traditional method, is that the system is expected to be a stationary system, meaning your average arrival rate and average departure rate is actually relatively stable. But in home construction, this is actually much more complex dynamic that basically break that assumption. So the proper approach to model this queue and understand where's the optimal efficiency would be is applying stochastic model and machine learning technique, which is applicable to complex model. We cannot assume IID or independence between phases, and also applicable for non-stationary systems. What even more interesting is actually home building industry, because of lack of data point historically, is very low observability. So for us to quickly jumpstart the machine learning algorithm, we basically applying all this simulation to basically allow us to deliver value immediately. To establish some basis for those who are not familiar with queuing theory, there's generally 4 types of queues. I'll use some example to illustrate them. The first type is single queue and single server. If you think about ATM or drive-through in the McDonald's, so you basically have to wait for the car before you is being served before you can actually move in. So single server, single queue is one type, the most simple model. And then single server, multiple phase is that you basically have to wait and be served at every multiple step like Chipotle, or if you think about college, your canteen at college, it's single server, multi-phase. Multi-server, single phase is like a grocery checkout. You have multiple checkout line, so every line is a server, and then you basically just one step to actually get it done. Now, the complexity in new home construction is a multi-server, multi-phase queue. You can take a look below as the major phases of a new home construction that has to cover, from sales to drafting to acquiring permit. Then you need to build a foundation before you can put the roofing, framing, and then put all the insulation inside and painting and carpet before you can actually have a customer to take possession. So that is all the variability that was introduced to the construction operation, and hence the reason why it was so difficult to manage it traditionally without modern technique. So take a typical home building single-family construction queue. The final sales take 45 days to basically get the customer to make final decision, what kind of home and customization need to be finished. And then another 30 days for the drafter to draft the home, 10 to 20 days to acquire permit and estimate the cost. And then they put the foundation, another 30 days, 25 days to frame, and 20 days for mechanical installation, and then 30 days for final walkthrough. But today, actually, in the current environment, the framing and roofing already has changed from 25 days to 140 days. So it's actually very, very different dynamic compared to historical sense. Then how do we apply machine learning to these queuing model? Right? So typically when you need to establish a mathematical model about queues, you need to understand the queue length and capacity constraint, which can be acquired from the business. Right? So what's the tolerance of queue, people that should wait in the queue, and what's the capacity you can allocate to your construction capacity. But what was difficult to manage was the arrival rate, which is basically the demand that going into the queue and exit to the next phase. We apply multivariate time series forecast, which actually able to create much more accurate forecast compared to a univariate time series forecast, because we simultaneously considering multiple kind of factors, from behavior pattern to market economic to local market intelligence and consumer preferences. So that is actually one use case for time series forecasting to model the arrival rate. We also apply non-stationary time series model to model the service rate. In that, we basically providing much better visibility to the actual capacity and service rate that a home builder can actually provide to the market. And more importantly, actually, we also help them by deploying all these data, the recommended system, we are collecting information directly from consumer. Again, basically hundreds of thousands of user sessions from online, rather than a couple hundred sales per year. So when we actually use those kind of model, we are able to establish the population distribution. And that is actually feed the basis for our stochastic model. So these are different applications that we actually apply machine learning into the QA models. So here I actually have a very interesting, very fresh case that we recently built a model for a few home builders. So this is a current situation of a home builder. Let me quickly walk you through the line. Different line represent different phase of the construction. Like I mentioned, pre-drafting, estimating, foundation. But the key line that I want to show you is actually that because there's a backlog of framing, so you can see the time it takes to take possession, even for all the homes that currently in their construction queue, is well beyond 2023. That actually, if you think from financial term, all these homes are being locked on the land. Actually, they are unable to, the home builder are unable to get the cash back until the home is taken possession by the customer. So how much cash actually, we're talking about millions of dollars being locked in the land. So this is the current situation, right? So you can see they will be able to finish framing, assuming no new sales. If they do not take a more proactive action, they won't be able to even finish framing by the basically by mid-2023, let alone actually taking possession of the home and getting the money back in the bank. So with that, we basically help them to establish a few different baselines, right? So the first scenario they want to run is that if I optimize my drafting and framing, which is the most challenging phases they were dealing with, how would that happen? So interestingly, our simulation and forecast model basically be able to illustrate that on the purple line, while you are able to control the framing to become much more effective to finish framing with that capacity, you can see the purple line was well beyond 2023 now to actually keep it under control roughly April 2023. But they basically pushing the problem downstream to the next step. So you can see insulation to texture actually kind of move through the roof if you don't actually optimize the entire construction queue. And if they actually optimize overall throughput by matching capacity to every single phase, you can see they are able to basically starting to get relieve the cash flow situation that they have roughly about mid-2023. So much better situation that they are currently facing if they don't actually take proactive action. Now, this is another scenario that if they basically maximize the framing capacity even beyond basically to the maximum capability they can have, how much more gain they would get. But you can see framing actually can be able to finish even earlier. But again, the problem will going to be pushed to downstream to the insulation and texture. So with that additional cost to basically further improve the efficiency in one step, doesn't really help them to acquire overall optimization. So that is basically the balance and the basic forecast view we're able to help home builder to know that how are they able to basically have a most optimal operation across the board. Of course, like all of those scenario that you're seeing is assuming there's no sales and how fast they can clear the current backlog. But the reality is actually a lot more complicated because they actually also have ongoing sales coming along. So we basically can push all those assumptions and sales forecasts, combining those to the current operations. Then we can basically give them a constant, ongoing view about how the operation will be looking like. And then they inform how can they execute their different sales strategy. Meaning in the times that the market is very hot, they can actually increase their pricing to capture more margin. And then in very cold, in a down market, they can also be more proactive to fill the operation capacity with their inventory homes and still basically be able to very effectively capture some margin from the market and supply to the market. Yeah, so we're basically building a few more exciting products to inform what are the most interesting options and structural features should be going to their product portfolio because powered by those algorithms. And we basically also provide all these insight intelligence in terms of reporting and dashboard, and that's how we currently deploying all this technology for every our home builder. Now, there's one fundamental difference compared to us and Amazon is that, or Netflix, is that our ambition is to deeply understand the market demand, and then also helping helping the supply side of the market to know what the demands want and reduce risk. But if you think about Amazon and Netflix, you probably won't be able to call them and say, can I buy your technology, or can I use the technology? So we have a different philosophy. Our ambition is to make technology very, very accessible for all these different businesses that need them. So that's high level what we do. While we actually face a very challenging and laggard industry, but that's actually our perspective to applying technology to traditional industry is that when we look at technology, they all in the past they basically is considered as magic or impossible, and on the current day they're always barely working, but in the future they will be considered just our daily life, and so we basically take it for granted. So that's what we do, and if you want interested to find out more, feel free to reach out to me, and feel free to ask any questions on the detail on what we do in the algorithm.
Thank you so much, Will. Now we have time for questions, so please post your questions in the comments and we'll bring them up. We'll start off with Terry's question. I'll post them and you can read them, Will, and we can go from there.
Is this system the BIM3 system? Sorry, I'm not familiar with what is BIM3 system. Maybe I can Google it. BIM3.
Terry, are you there? Are you able to type in the comments a little more information for Will?
So I would assume actually some kind of existing system in the industry. So we actually take a very API first approach when we deploy technology. As you guys can imagine, home building is a very laggard industry. A lot of outdated and proprietary technology already in place. But fortunately, it's actually most of these systems are either, they do have a database and the database is accessible. So what we do is basically we build these different type of connector, and our technology is all deployed in the cloud. So we basically connect to the existing system, extract whatever is meaningful information from them, and then, if you understand, basically we're collecting data directly from the consumer, and then we're able to blend all this information and run optimization model for them. So I'm not, Terry, I'm not familiar with the BIM3 system, unfortunately, but in general, if it's actually an existing system that we are aware of, we typically can build connectors to connect them. After all, that's the advantage of cloud technology, right? So. Okay. So the question is, I have one chart showing consumer index utility plotting on the y-axis. And how do I estimate the utility metrics? So this is actually, we basically observe from the actual historical sales how many changes that a customer will actually apply to. So by looking at the choices option that they customize to their home, then we basically can understand how many actual choices and selection do they actually apply and be delivered to actually making those changes. If you actually pay attention to this chart, I actually apply log scale on the other axis. So that's making like a straight line, but the reality is actually exponential. This chart is essentially to illustrate that, in fact, consumer doesn't really need that much choice. Sometimes we need certain degree of customization. That is, a lot of time the outcome of the design was really not targeted for the specific segment. So if we can actually, based on behavior pattern, to anticipate what are the demand of each segment, then you actually can, a professional designer will typically be able to set a really good baseline. So it's almost like if you think about how many choices you have to make if you're buying a Civic versus how many choices you actually needed to make if you go into a Tesla, go to buy a Tesla. So it's very, very different, right? Or even for those who have used phone before the time of iPhone, there was so many choices about phones, but the first version of iPhone is just only one iPhone. So a lot of time, the industry has this perception that more choice means better customer experience. That's not necessarily the case. So this chart is actually to illustrate that there's actually a utility curve that can be actually applied mathematical model to find the optimal spot to balance the complexity of operation and a targeted customer segment that what would be the best utility and choice level that they should have. I hope that answers your question.
Okay, so if there are no further questions, thank you, Will, for your great presentation. It has been quite insightful. And I'd like to thank all the audience for showing up. Our next talk will begin at 1 p.m. Oh, sorry, there is one question.
Mm-hmm.
You can.
You mentioned roofing revenue is reasonable to net. Is that due to supply chain issue? Yeah, that's a great question, actually. That is a combination of an issue that, let me actually go to the simulation here. That was an issue that related to a few things. One is that the market was super hot last year, actually even now. So they actually oversold the capacity they're actually able to do. Now, framing also, there's a long-lasting labor issue, a shortage, because based on my research and our understanding, the carpenter is a very, very very labor-intensive job. That there's only a limited number of framer that exists in every geo market. So, so you have a fixed supply in every city, in general. But then when everyone oversold, the reason all of a sudden you basically have a very limited capacity that can supply to us. But all home after they've done the foundation, they basically all stuck there. The issue is also they were not able to see that coming because traditionally framing, as you can see, it's only take 25 days to 35 days to finish. So they were unaware of the constraint that actually exists in the market. Now, if they're paying attention to the operations, there are a lot of early signs that actually they're able to see it, but the problem is they're always reactionary. By the time the operation team take action and voice out on the material cost increase and labor limitation, it's a bit too late already. So then you basically have this huge traffic jam that creating a bottleneck for framing problem. So that again illustrates the issue that if you're unable to see the problem ahead of time, you cannot really throttle the input from the entering the queue, and that caused this situation. So even in one of the simulation we run is similar like that, right? So now they have framing and drafting problem. If they starting to control the framing and drafting, it actually only shifts the problem immediately downstream to insulation texture. But that's not that obvious unless we run some kind of simulation model to showcase that. So yeah, it's actually very, very challenging due to the complexity of construction. And that is unfortunately where the bottleneck manifests itself.